This is SRG, Faculty of Chemistry from Narayana IIT Academy, India. Let me have the discussion of the questions collected from the students' memory. The IIT JEE mains examination held on 6th of September, morning session. See, let me have the questions. In case of the morning session, the question, here you can see the first question is, there is a triple bond for the aryl compound with one is strong minus M effect and another is strong plus M effect. Now for this, in presence of Hg plus 2, mercury ion, addition of the nucleophile H2O. That is the question. See, when there is addition of a group towards triple bond, we know it is relatively less electrophilic. Because of less electrophilic character, we can identify the addition reaction for the triple bond takes place mainly in presence of any metal ion that catalyzes the reaction. In presence of Hg plus 2, first a transition state is formed. This transition state with mercury, that is mercury ion. Now this is added with further the nucleophile. While nucleophile is adding, nucleophile open this transition state, and the opening of that transition state takes place from the direction where there is sufficient electron density, because even this is a simultaneous addition. There is a partial, very less fraction of the time we can identify partial charge, positive charge is developed over the carbon. So for this addition, Hg plus 2 is shifted towards one of the carbon atoms, and nucleophile H2O is added towards another carbon, an intermediate, which further, with the loss of Hg plus 2, enol is obtained. So this is enol form. Enol form is unstable, which further rearranged into by presence of H plus. This catalyzes keto formation. So enol to keto is obtained. That is the final step, the product. Tautomerization takes place here, that is catalyzed by H plus ion. Now you can identify this ketone form is existing in two options 2 and 4. But what I said, the ring is opened here, transition state ring, in the direction where there is here the electron density more, from that side the ring is open. The electron density is more relatively supported by OCH3 group, that is strong, one of the best plus M affecting group. So here we get fourth option is more accurate, that is the correct option. Let me proceed for next, another one, second question. See, in this second question, write down increasing order of pKb of for following. This we have to identify, because the options carries the order of Kb and also pKb. We know for the stronger base, Kb is more and pKb is less. So related to that, see here amine derivatives were given, aryl amines. Aryl amine that has nitrogen with alkyl group, that is 2 methyl groups. And now in this case, the lone pair of nitrogen, it can be donated towards the existing acid. That donation is now depends on the group which is attached to the aryl system, because this will start influencing electron density over the nitrogen. So when we see the group here, methyl group, it is plus R affecting, and there is no sub effect over this. Only aryl system has minus M effect from this, and minus I is dominantly observed. Next, here cyanide at meta position it is. When it is at meta position, there is minus I effect. And one can identify methyl group along with plus R, it also shows plus I effect, positive inductive effect. Here there is minus I, negative inductive effect. Next is OH. OH also exhibit minus I, negative inductive effect. Now there is a comparison between cyanide group and also OH. We know if heteroatom containing lone pair is attached to the aryl system, this has much tendency of donating electron towards aryl system. Because of that reason, there is here plus M effect and minus I, but for this position, mesomeric, that is at meta position, mesomeric effect is not considerable and inductive effect. But inductive effect is also influenced by the mesomeric effect in this case. Now when we see carbon is less electronegative than the oxygen, one may expect carbon is less minus sign, but there is a heteroatom with a multiple bond towards the carbon. If more electronegative atom is bonded with multiple bonds to the atom directly bonded to aryl system, then it is electron withdrawing group. Because of this migration of electron here, this is relatively more minus I effect compared to that of OH. So more is the minus I effect, then more it will causes electron density availability to the least values. Less availability of nitrogen lone pair towards the donation means for the basic strength. Because of that, here you can identify one is more basic. So here I am writing Kb values order, which is more basic. 1, after that it is 2, then the basic strength is for 4, and after that basic strength is for 3. This is the order of Kb. But the question is about pKb. So what is the order of pKb? Exactly a reverse order here. 1, 2, next is 4, and after that it is 3. And one has to identify, in case of amines, the basic strength not only depends on lone pair availability, means evidence of electron, but also another factor, that is the stability in aqueous solution. Default, even it is not specified, default it is in aqueous solution. In aqueous solution, lone pair of nitrogen after donation towards proton, if H plus is added here, nitrogen becomes positive. Now there is the solvation here. This is solvated. All these they get solvated here also. Stability of this conjugate acid, that will decide. This is also another factor which influence, also the second factor which influence the basic strength of amines. But here solvation of these is not much affected. The reason, there is no substituent around these. In these cases you can identify there is no substituent. Because of that, solvation is not affected. Almost they have equal extent of solvation. Now only the factor is remaining what we had discussed. So relative to this, here you can identify this is the PKB order. PKB order is present 1 next to 4 3. Third option is correct for this. Okay, let me proceed for the third question. In case of, see in this third question, there is a group with a good leaving group is given. The molecule OSO2CH3, this is a leaving group, good leaving group. Tertiary butoxide and heating, high temperature is specified. Tertiary butoxide is bulky group, that is the base. We know tertiary butoxide CH3, this is tertiary butyl group, and O minus. Okay, tertiary butoxide, that is a bulky base. Bulky base, when it is approaching with the molecule having a larger leaving group, mainly this will proceed towards beta carbon. Temperature is there, so there is no doubt at all with good leaving group. And why I said it is good leaving group, we can see CH3 SO3 minus. This has sufficient resonance stabilization.